Adding and subtracting mixed numbers. Okay, let's say we wanted to take 1 3/8 and we're going to add 2 4/8. And we want to find out what we get. Okay, so 1, these are all split up into eighths, but when I'm doing the whole number part, I don't really need to draw all that in because I'm just going to shade the whole thing anyway, right? That represents 1, so there's 8/8. I just shade the whole thing. Same thing over here. There's 2. I don't really need to split this up when I'm drawing my picture because it all gets shaded in. So there's the 2 for that one. But when I'm doing the fractions, then yes, I'm going to need to split this up into even sections. Okay, same one over here. Same thing over here. They're both into almost identical eighths. Okay, 1, 2, 3, 4, 5, 6, 7, 8 pieces. So when I want to use this to represent 3/8, I'm going to shade in 3 of those slices. 1, 2, 3. So now this is a picture of 1 3/8. And over here, okay, for the fraction, I'm going to do 4/8. So I'm going to shade in 4 of these slices. So 1, 2, 3, and 4. Okay, so this is a picture of 2, 1, 2, and 4/8. Here's the 4/8. So what does this equal? Okay, well, I've got 1, 2, 3 holes. Okay, so if I want to draw a picture of that, I would have 1, 2, and 3 holes. Okay, and those are all shaded in. Okay, I'm adding them together. Now, I have the same denominator, right? The picture's the same. This is 8 slices, this is 8 slices, so I can just add them together. So there's 1, 2, 3 shaded pieces on this one, and there's 1, 2, 3, 4 shaded pieces on that one. Okay, so I can add the 3 pieces and the 1, 2, 3, 4 pieces together. So I'll draw another circle in eighths, and I want to shade in my 3 pieces from this one, and then my 4 pieces, 3, 4, from that one. Okay, and so now we have a picture of what 1 3/8 plus 2 4/8 is. So we got 1, 2, 3. Okay, so this equals 3. And then we have 1, 2, 3, 4, 5, 6, 7 of the eighths in this one. So 3 7/8 is what we get. So that's how we do it pictorially, or if you're using manipulatives, and we can also do this algebraically. So we're going to take mixed numbers and we're going to add them together. So 1 3/5, let's add that to 2 4/5. Okay, so to add these, obviously these are mixed numbers. You have integers and you have fractions. So if they were both fractions with the same denominator, then we already know how to add those together. It's pretty straightforward. So let's just make these fractions with the same denominator. Okay, so 1 can be rewritten as 5/5. Right? 5 divided by 5 is 1, or 5/5 if I was drawing that as a circle and all 5 of the 5 were shaded, that would just be a whole, right? So 5/5 and 3/5, that gives me this number right here. Okay, that's this one right here. I've just done that one. Now over here, let's do this one. So 2, okay, well 5/5 is 1, as we said, and another 5/5 is another 1. So that's 1 plus 1, that makes 2. Okay, so there's my 2 taken care of. And then the 4/5 is 4/5. Okay, so those are 2 separate numbers. Okay, so let's do this one first. Same denominator, so we just add the numerators. 5/5 plus 3/5, that equals 8/5. Okay, now second number. Again, all the same denominator, so we add the numerators. 5 plus 5 is 10, plus 5 is 14. So now we have 14/5. Okay, so 1 3/5 plus 2 4/5. Okay, we can turn those into improper fractions, and we can add those together. And again, we have the same denominator, so we're just going to add 8 plus 14. That equals 22/5. 22/5. Okay, so now we have to take 22/5, and we have to turn that into a mixed number. Okay, so we have to figure out, well, how many holes do we have in here, right? We already said 5/5 is 1 hole, right? 5/5 is 1 hole. So if we take away 5, that's part of 22. There's certainly another 5/5 in there. That is another part of 22. There's another 5/5 in there. There's another 5/5 in there. Okay, so if we have that, there's 5 and 10 and 15 and 20. Okay, and we need to get to 22. So we need 2 more. Okay, so we're taking this number 22 fifths and we're breaking it down. 5 fifths and 5 fifths and 5 fifths and 5 fifths, and then there's 2 fifths, right? We add up all these numbers and we get 22 fifths, which is our number here. So, of course, 5 fifths is one whole. This is a whole, this is a whole, this is a whole. Okay, so we can add those up together. 1, 2, 3, and 4. And then we're left with 2 fifths. So 4 and 2 fifths is the answer for 1 and 3 fifths plus 2 and 4 fifths. We can also subtract mixed numbers, okay? We can subtract mixed numbers. And so we can do it the way we just did, which is algebraically, we break it out into a improper fraction, or we can look at another way of doing this, which is just the wholes and just the fractions. Okay, so here I have 4 and 5 eighths, and I want to subtract 1 and 3 eighths. Okay, so let's look at just the integers, right? Let's look at 4 minus 1. Well, that's 3. That's pretty straightforward. Okay, but to solve this equation, I need to take 5 eighths and I need to subtract 3 eighths. Okay, so let's do that as well. 5 eighths and subtract 3 eighths. 5 eighths minus 3 eighths, same denominator, so I just subtract the numerators. 5 minus 3, that leaves me with 2 eighths. Okay, so once I put these together, I have the solution, and that's 3 and 2 eighths. Okay, so we can add and subtract mixed numbers by using pictures. We can do it algebraically by changing mixed numbers into improper fractions, and we can also look at just the whole numbers and just the fractions separately.